This lesson deals with supplemental problem 316. You can find this problem in the ECE302 ebook in the Chapter 3 Supplemental Problems on page 22. The collector emitter voltage in supplemental problem 315 varied with a value of beta F. As beta F got larger and larger, we approached 0.7 volts. We'll see a little bit later in the course that we don't want to have a voltage that small across the collector emitter when we're trying to swing an AC signal. Try replacing the 10K resistor with a Zener diode to fix this. Redesign the circuit and place the transistor at a collector current of 5 milliamps and a collector emitter voltage of 5 volts, if beta F is 100. Here's our proposed design. We're going to replace the 10K resistor by a Zener. Current again is going to come out of here, go back this way, and go back this way, back to the power supply. Put in our active region model of EB on of 0.7, a beta FIB of 100, where here's the V sub B entering the base. And then we're going to be in the Zener region. Let's label this as V sub Z, and we'll solve for the Zener value. From our specifications, we want this voltage to be 5 volts, and this current here to be about 5 milliamps. We can go around the loop here and solve for the Zener voltage. It's going to be this node voltage minus this node voltage, 5 minus 0.7 or 4.3. I looked on the web and I found there was a 4.3 volt Zener, half watt. It was a 1N5229. Let's use that particular Zener diode. And now let's solve for the current I. This current is equal to the base current plus the collector current. That's really the emitter current. That's roughly the same as the collector current. Let's find the voltage across this resistor and then divide by I. We can get the value of R. This is 9 volts, this is 5 volts, and dividing by I. And I is approximately 5 milliamps. That would give us about 800 ohms. Here's our final design. We got the current I is equal to IB plus I sub C. That's going to be equal to beta FIB plus I sub B, so beta F plus 1 I sub B. The base current is going to be this current, which we set to 5 milliamps up here, divided by beta F plus 1. It's going to be 49.5 microamps. Again, pretty small. And the collector current will be 100 times bigger, which is 4.95. We're shooting for 5 milliamps, but it's a little bit smaller than that because this current is not exactly the same as this one, but close enough. And lastly, have we picked the right wattage of the Zener diode? The voltage across it is 4.3, and now the current through is a base current, which is pretty small, 49.5 microamps. That's only 213 microwatts. So we're way below the 500 milliwatts or half watt rating of that particular Zener diode. This now will force a larger voltage across here, give us a better swing when putting an AC signal in. And this is supplemental problem 316.